Hi, in this video I'm going to make a 3D scan of this bicycle helmet and then I will reverse in CAD using Autodesk Inventor and Patch Surface. It's a standard tool, so I don't need any third-party software to do this. So the easiest way to reverse it, I will be using the Surface tool to do this. Okay, let's fast forward to Autodesk Inventor. To create a surface, you will need a 3D lines, and what you see here is the arc in a 3D space that extract from a 3D scan model. So if you can create good typology, a 3D arc like this, you can then create a surface by using patch command. So when you click on the 3D lines and create a closed loop, then you can create a surface. It can either be 3 size or more. For example, I can create a very long strip like this. So if you have a closed loop 3D lines that you extract from the 3D scan, then you can create a patch surface. This will be a full surface created by using patch command, and from the patch command, you can create a thickness of the shell by using a thicken function on the Autodesk Inventor. So now you have a solid shell. I found that is easiest way to retrieve the 3D line is by using a blender, the free blender. I will import the mesh from the 3D scanner, and then I will build a plane and shrink wrap it over the surface of the 3D scan model. This plane has already shrink wrapped it. I will export this plane into the XF format, which is the CAD format. After I export it, then I can directly import this as a 3D lines. This is a 3D lines, but it will contain only straight line, not an arc. So I will use this straight polyline to create arc lines like this, and use this arc line to create a surface, and use the surface to create a solid. Okay, it sounds complicated, but it's I found that by using the blender, it will be fast and easy to reverse a complex surface with blender, because blender has a surface snapping tool and it's very fast and it works very well. So you can adjust or move the vertex anywhere and it will snap directly onto the surface. Okay, let's get started with 3D scanning. And the scanner that I will use to 3D scan this helmet is MAF3. So this helmet is considered to be a large size object for the MAF3. Because MAF3 is a turntable-based 3D scanner, it will align object in a full rotation of the scan by using the calibration of the turntable to stitching the individual scans together. For this helmet, I will make 6 scans in one rotation. I will scan in this position, and then I'll flip over to scan in this position, and then I will probably adjust the height and make another scan angle in the taller position, so I can capture all of the surface of this helmet. But I wouldn't be probably able to scan overall inside of the helmet because there is a shin strap and some of the tightening device that I cannot remove. So this helmet size is about 30 centimeters. MAF3 can scan this object without any issue. Some people ask what is the largest size of the object that is suitable for making a 3D scan on this turntable. I would say this is about 40 centimeters. I would say this elegant case can be scanned on this turntable, but I need to adjust the clipping plane. I mean, this 3D scanner has a cut out radius of 30 centimeters. So anything that is larger than 30 centimeters in diameter will be cut out. So when it's scanned, it cut out everything that is a little bit larger than the turntable. But you can set this in the setting of the 3D scanner to scan something larger. And for this one, I need to set it to about 40 centimeters. Okay, before I start to do 3D scanning, this object has a white color and also the black color of the foam. So it's a very high contrast color. So I will do a spray in the black part so that the black part will be captured together with the white color of the shell. Because this helmet is water washable, I can wash this after I make a 3D scan, so I can spray. And okay, let's start with the spraying. Okay, this will be my first orientation. If you touch the white part, it won't affect the scan, but if you touch the black foam, that part won't be captured. Okay, I will add the scan and adjust the position of the 3D scanner. I'll move it a little bit backward. I try to put it as close as possible, as closer to the object as possible. I think this will be the closest. Okay, and then I will adjust the exposure a bit too bright. Okay, about this 90. And for the capture, I'll use medium, but I will turn off the texture because I don't need it. And for the turntable, it's going to be 6 round. I will position the focus point to the center, a little bit lower. And then I will calibrate the scan. And I will put this on the table first. I use the larger calibration board because it's quite like 50-60 centimeters from the object. The 3D scanner knows the rotation axis of this turntable, so it will be able to stitch the 6 scans together without using the geometry tracking. Okay, here's the first scan. See that all 6 scans align perfectly. Okay, I flip this helmet over and then I make the second scan. I'm going to put some clay to support it. Because I didn't move the turntable or the scanner, so I can start the scan immediately without calibration. So I have 2 scans, table 1 and table 2. This is the latest one. I will remove the clay using the lasso tools. The clay is removed, and then I will merge the first turntable to the second turntable. So the first and the second turntable scan is merged, but I still need another scan, a scan from the top of the helmet, and also try to scan as much for the inside of the helmet. So what I'm gonna do next, I'm going to create a group and put the first scan into this group, second scan as well. So this group has 2 scans. So my third scan will be merged to the group 1. So it will be easier to merge because it has a lot of point clouds. So I will add the scan. This table is adjustable, so I can adjust it to be taller. So now it's taller. You can move it like so, or move it down. Okay, so now I can see the inside of the helmet, a little bit of the outside. I moved the scanner, so I need to recalibrate it. Put the calibration board. I forgot to adjust the camera. So there will be 4 scans in total. This is third scan. I will press it here. Okay, here's the third scan. I'll try to merge it to the group 1. Because there's some overlap area in the back, I think it should be able to merge it automatically. I'll click on auto and group 1 and the turntable 3. Okay, it's most successfully, but I can't scan to the bottom of the helmet because the chin strap block the projection of the scanner. I need to cut the chin strap to be able to scan overall inside of the helmet. So I just leave it because I only need to use the top gel. Some part of the top is not scanned. I flip the helmet over and make a 3D scan on the top. Add scan. This will be the view from the top. So start scan. So the turntable 3 has already been aligned, so I put it in the group 1. This is the turntable 4 that we just scanned. I will merge the turntable 4 to the group 1. Auto, group 1, turntable 4. Okay, it's merged successfully. I think we have all the outer shells scanned. I will move this into group 1 and rename it helmet point cloud. So if I want to use it as a point cloud, I can export this in this step by choosing the export. Choose the XYZ. That will be it will be the same as the ASC format, and then I can open it in Cloud Compare. In this video, I will reverse using the surface, so I need to use it as a mesh because I will put it in Blender to create a shrink wrap of the plane. So I will use it as a mesh. To do that, I will click on Merge Scan, and then I will merge the point cloud, and this will convert this into a mesh. So I will mesh this. It will close all the openings and make a concealed model. So now the helmet has been meshed and it's all closed up, and from the inside you might see that it has incomplete scan because of the chin strap blocking the projection. But I'm not gonna use the inner shell anyway for this tutorial. So I will add this to the project. I don't need to continue with the step 2 because I don't have texture, color, scan. So I will add this to the project, and then I will export it. So this is the mesh that to be exported. I rename it raw mesh for a YouTube tutorial. I will click here and click on export. I will export it as an OBJ. I don't need texture, and scan has already been merged, so I don't need to click this. I click on export. Okay, and then I save it. Okay, here's in Blender. There's 3 standard item. I will delete it, and then I will drag and drop the OBJ files that I export from the math tree. Drag and drop. For the scale, I will use 0.001. Import it. Hit home one time. Now your helmet is here. I click on N. Unit is in the meter. I'll change it to centimeter. I do it here, units centimeters. Now I check the size, 28 centimeters. Okay, that's correct. 28, 16, 21, XYZ. Okay, I will adjust the orientation of the helmet. I click on R, go on the sides, go on the top view. See here, I move it to the center. You see here, this the front part and the rear part that has a marking that I can align it to the X axis. So I try to align it. I move it up, GZ, move up. This should be it. Okay, next step, I will click on here and click on random color so that the helmet and a new plane will have a different color, so it's easier to see. Okay, next I will click on add mesh and plane. You have a huge plane here, 2 meters. I only need 1 by 1. Size of the plane should be smaller, 1 by 1. And then I will move it to the front, move it up here, go to the left a little bit, and then I will rotate it to the, this one is y-axis. I rotate it minus 90 degrees, right? Next step, I will click on this object and click on the modifier, add modifier. I think it's somewhere here, deform and shrink wrap. Okay, now click on the eyedrop tools and click on the helmet. Now the new plane that we just created is wrapped into the surface of the helmet. I click here and click on apply. Before we do anything further, I will click on, I think it's here. Okay, here, viewport display, this one. The object and click here in front. Now our create plane will be in front of the helmet, so it's easier to see. Next, you need to enable the snapping tools on the top here and click on the face. Now whatever you do, it will glue it to the surface of the helmet. Okay, now I click on the plane and rename it shell, and then I enter edit mode. After you enter edit mode, I will click on the vertex selection tools, and I will use the lassos tools for selecting it. Now you can move by hitting a G. You can move the vertex anywhere you want. Because of the helmet is symmetry, so I will create only one side of the shell. And to do that, I recommend that you move the shell just a little bit over the center of the helmet. You can trim this in Autodesk Inventor after you complete the shell modeling. Your next process would be using the mouse selected and click on E to extrude. This is the way that you can add more vertex to the model. Just keep doing this. When you select 4 of the vertex, you click on F, that it will create a plane. One of the plane can contain at least 3 vertices, and like this. So what you need to do is that you keep extruding. So if the line is not straight, what you have to do is that you reposition it by clicking on a G, and you can reposition the location of the vertex. Click on E to extrude a new point. Now it's done. So I will create a plane. F, hit on F. Okay. When you come into the corner, you need to create 3 vertices, so that when you are in the CAD, you can use these 3 vertices to create an arc, because you need 3 points to create an arc. So this 3 point will be reference for making an arc. You see this point, see a small groove here, and the helmet start to change the surface shape in this location. So I will start it here. I will stop it here to make you example. F, there's a lot of F word, isn't it? Okay, now I'm going to extrude this. This will be a very fast and easy way to reverse the complex surface. You don't need any third-party software. It's not necessary. And let me model this one. Blender is perfect for reversing complex surface. It works with the space mouse, and you can use the pen tablet if you need more accuracy. And I will make a face fill it. If your line, the edge here is too far, you can split it in half by doing this. On the right click on subdivide. See that? You have extra vertex in the middle. So if you do the same for the other side, subdivide. Now you have a smaller face. Okay, let me extrude it a few more. I'm going to make a step here. I think it's gonna blend in somewhere here. This can be wrong because when you move the vertex, or when you create a new vertex, it will snap into the surface of the model. So if you have a clean scan like this, you'll be able to make a reverse very easy. You can, if you want to go deeper, you can do so like this. You need to select all the vertices. If you want to go to the lower part, you can do so. Okay, here's just an example of how you create the faces in the Blender. It's quite fun actually. I really like it. It's easy. No, it's nothing difficult. You can also reposition if you've done something wrong too. So you need 3 points to create an arc. If you do this for a while, you start to learn how easy it is to reverse using the Blender. Okay, now I'm done. I will show you how to export this back to the object mode. to export the 3D lines. I click on Files, Export, and there will be a tool called AutoCAD DXF. Before you can see this function, you need to add the add-on. There is an add-on. Click on Edit Preference, Add-on, and then you go to, I think it's here. Yeah, here. Export AutoCAD DXF format. You go to this website, extension blender.org, and search for export AutoCAD DXF format. Click on get an add-on, and it will install this add-on into your Blender, and then you'll be able to have see this function. And when you click on export, you need to select the item that you want to export. Click on AutoCAD DXF, export mesh as. You click on line. So you don't need faces, you need lines, because the Autodesk Inventor, it works with 3D lines very well. So you need to select on lines and click on export. Your files will have a meter unit, not millimeter. So when you import into Autodesk Inventor, make sure that you select meter unit. Okay, I'm going to open the one I just made. I didn't do the whole shells because it will take too long for this video. I make only this top part of the helmet on one side. One mistake that I made is that I draw it in the exactly center of the helmet instead of being extended a bit to the right, so I can trim it later. Doesn't matter, but something that you should know. Okay, let's move to Autodesk Inventor. Okay, here's 3D lines that I import from the Blender directly into the Autodesk Inventor. Next step, I will have to create an arc, because this one is a straight line, it's a segment line, but what I need is a smooth curve and the arc to create a surface. So I will make a new 3D sketch, and with this 3D sketch, I can snap it onto the polyline that I import from the Blender. So I just keep making the arc line. It doesn't have to be a small segment, can be larger like this. See here, and then I make a arc line. Just keep drawing the arc lines like so. See here, it's very easy. It doesn't take long time for this helmet. You probably can do this in half an hour. See my complete arc line that I create with the patch command. I think most of the 3CAD software has this function. It's a patch command. You can create any kind of surface inside of your CAD software. The only thing that you need is the 3D line. So I just keep on doing this. It's a surface that I create with this method, and if I want to thicken the shell 0.5 millimeters, so this will be one single solid of the shell that you can use it for. I mean, you're not going to print a helmet, it's a safety device. Okay, thanks you guys for watching. I'll see you in the next video.